A fortress wall in Peru defies earthquakes and time with stone blocks that fit like a perfect puzzle. This is Sacsayhuaman, and its indestructible walls hold a secret that rewrites the story of human ingenuity. By the end, you will understand the profound system of knowledge that built something our modern engineering struggles to explain. How did a civilization without wheels or iron create walls where not even paper can slip between the stones? What forgotten method allowed them to move rocks heavier than a bus across mountain valleys? The answers lie buried in myth, science, and stone. What does it truly mean for a technology to be lost? This vision transforms a hill into something far greater. To the Inca, the city of Cusco was not just a place of stone and streets. It was a living, sacred puma carved into the landscape. The Fortress of Sacsayhuamán formed its fierce, watchful head, perched high above the river that shaped the puma's spine. This was no whimsical metaphor. It was a fundamental principle of their world, a zoomorphic design where architecture, geography, and cosmology were woven into a single, powerful intention. The hill was chosen not merely because it was defensible, though it certainly was, but because it was a place where the earth reached closest to the heavens, a nexus of spiritual energy. Every decision, from the grand layout down to the placement of a single rock, was made within this framework. The walls did more than repel invaders. They channeled water in sacred patterns. They aligned with the solstice sun, and they projected an aura of divine, unshakable order. To stand before them was to confront the head of a stone puma, a symbol of both imperial power and celestial protection. So when we search for their lost technology, we must expand our definition. It wasn't just a toolkit for shaping rock. It was a holistic system of knowledge that began with seeing the world as an interconnected, living entity. The genius is in the integration, the seamless blending of the practical and the profound. This mindset, this sacred geometry, is the first key to unlocking the mystery of the stones themselves. The true scale of the task becomes clear when you stand beside one of the larger stones. Picture a block of solid volcanic rock, taller than a two-story building and heavier than 20 modern cars. These are not mere bricks, they are geological titans, some weighing well over 100 tons. And the first, most fundamental question is a simple one. Where did they all come from? The answer is a journey in itself. The specific type of andesite used at Sacsayhuamán was not found on the hilltop. It was quarried from sites several miles away, across a landscape of deep ravines and steep mountain slopes. This creates a breathtaking logistical puzzle. How do you move 100-ton stone without the wheel, without iron tools, and without beasts of burden like horses or oxen, across miles of punishing terrain? The sheer physicality of this problem forces us to abandon our modern assumptions. The solution was not a single magic trick, but a symphony of human ingenuity and communal effort. Researchers point to a likely system of earthen ramps, woven fiber ropes of incredible strength, and teams of hundreds of workers using wooden rollers and levers. Some legends and modern theorists suggest even more esoteric methods, like the use of sound or specific vibrational frequencies to reduce friction. Ideas that, while controversial, speak to the profound mystery that still surrounds the site. The choice of stone itself was deliberate. This volcanic rock is exceptionally durable and could be worked with stone tools, but moving it was an act of social engineering as much as physical engineering. It required a level of organization, shared purpose, and knowledge of physics that rivals the great pyramid builders. This initial mystery of the megaliths sets a staggering precedent. If moving the stone seems almost superhuman, then the next step in the process defies logic entirely. the stones, once in place, presented an even greater puzzle. It is in the joints between them where the real magic of Sacsayhuaman lives. These are not simple, straight seams. Each block is a unique, irregular polygon with anywhere from 6 to 12 sides, and sometimes more. Their faces are not flat planes, but subtly curved and angled, creating a three-dimensional stone puzzle of staggering complexity. The fit is so impossibly tight that for centuries, people have said you cannot slip a piece of paper or even a razor blade between the stones. This is not hyperbole, it is a physical reality you can test yourself. The effect is one of a single, continuous rock face that has been gently folded and knitted together by some giant, meticulous hand. This polygonal masonry is the core of the wall's legendary strength. Unlike a wall of uniform rectangular blocks, which has straight, continuous lines of weakness, this interlocking design has no straight fault lines for seismic energy to follow. When an earthquake strikes, the energy is dissipated across a labyrinth of irregular joints, causing the entire structure to shift and settle as a single, resilient mass, rather than cracking and collapsing. It is ancient anti-seismic engineering of the highest order. But how was it done? How do you carve two massive, irregular stones so they meet with micrometer precision across every inch of their complex, curved interface, all without modern lasers, computers, or even simple metal calipers? One compelling theory involves a process of iterative fitting. Perhaps the masons would roughly shape a stone, then raise it into position next to its neighbor. They would then use a colored paste or clay to mark the high points where the two rocks touched. Lowering the block, they would carefully grind away only those marked spots, then lift it again to check the fit. This painstaking cycle, repeated dozens of times for a single stone, would gradually create that flawless, custom joint. It speaks to a culture with immense patience, a deep understanding of stone's properties, and a workforce organized around a goal of perfection, not just speed. Yet, this method leads us to an even more perplexing question. What tools could possibly execute such delicate, precise work on rock as hard as andesite? The precision of the joints presents a tool conundrum that deepens the mystery. We know the Inca had bronze, but this alloy is too soft to effectively quarry or carve the volcanic andesite of Sacsayhuaman. It would blunt against the rock almost immediately. The standard toolkit, according to archaeologists, consisted of harder stone hammers, simple bronze chisels, and abrasive sands for grinding. Experiments using only these items can, in theory, shape the stone, but they cannot explain the scale and speed required to build such a monumental site within a single generation. The math simply does not add up, creating a frustrating gap between the tools we have found and the work we see before us. This void in the evidence is fertile ground for speculation. Could there have been tools made from a harder, now lost alloy, perhaps a unique bronze mixture that has since corroded away? Some researchers point to intriguing artifacts like the peculiar stone spheres discovered near ancient quarries. These could have been used as heavy pounders, or perhaps even in a system of rolling or ball milling to crush rock into abrasive powder with greater efficiency. Another theory involves thermal shock, known as fire setting, where a rock face is heated with fire and then rapidly cooled with water, causing it to fracture in controlled ways. Yet, even these clever methods struggle to account for the final, polished perfection of the polygonal joints. The absence of a definitive tool set forces us to consider two equally profound possibilities. The first is a culture of almost unimaginable patience, where generations of craftsmen devoted lifetimes to a single, grinding process of fitting and refitting, a communal act of devotion that transcends our modern metrics of productivity. The second, and more tantalizing, is that we are missing a key piece of technical ingenuity, a simple but brilliant principle of physics or material science that has been forgotten by history. This thought naturally pulls our focus from the tools themselves to the hands and minds that wielded them, and to the very method of the stone's transformation. The legends whisper of a secret more alchemical than mechanical. Among the most enduring mysteries is the idea that the Inca did not just carve their stone, they persuaded it. Early Spanish chroniclers like Garcilaso de la Vega wrote of a legendary plant whose juices could soften the hardest rock, allowing masons to mold and imprint it like wet clay before it set back into eternal hardness. It is a story that feels pulled from myth, a magical shortcut that neatly solves the puzzle of the impossible joints. Modern science, of course, is skeptical. No known plant extract can literally liquefy solid andesite on a scale useful for building a fortress. Yet, to dismiss the tale entirely is to miss its potential kernel of truth. It points us toward a sophisticated, and perhaps lost, understanding of stone not as an inert obstacle, but as a material that could be interacted with, even negotiated with. Researchers have identified plants native to the Andes, like the pulpy sacra, which contain high levels of oxalic acid. This compound can indeed chemically etch the surface of certain stones, creating a softened, workable layer. Imagine not a rock turning to clay, but its very surface becoming slightly more malleable, more receptive to the grinding of abrasive sands. This would not be magic, but a form of ancient chemical engineering, a deliberate alteration of the stone's surface properties to make the final, precise fitting less Herculean. The theory expands further into the realm of geopolymer chemistry, the idea that certain natural minerals, when mixed with organic compounds and activated by heat, can create a paste that binds or even mimics stone. Could the Inca have used a slurry of crushed rock, plant acids, and heat to fill the final, microscopic gaps between blocks, creating that seamless, monolithic appearance? When we look at the walls not as a static puzzle but as a dynamic process, the legend transforms. It becomes a metaphor for a holistic system that combined thermal, chemical, and mechanical forces. The goal was not brute force but intelligent reduction. A fire might be used to expand a fissure, a plant juice applied to weaken a crystalline structure, and then stone tools employed for the final, precise dressing. This integrated approach would leave little trace for archaeologists to find, as the final product is convincingly just solid rock. The stones themselves may hold the only clues, not in grand markings, but in the subtle, microscopic texture of their surface, a silent record of a conversation between human ingenuity and the mountain. The ground here has a memory of violence. Peru rests upon a restless tectonic boundary, where the Earth's plates grind against one another with unimaginable force. This landscape is not static, it is alive, trembling and heaving over centuries, and this simple, brutal fact transforms our understanding of Sacsayhuaman from a fortress into something far more brilliant, a dialogue with the planet itself. The Spanish conquistadors who built their own structures directly upon the Inca foundations learned this lesson the hard way. While their colonial churches and mansions of cut stone and mortar have been shattered and rebuilt time after time by earthquakes, the original Inca walls beneath them have not so much as shed a stone. They have stood unbroken through quakes that would level a modern city. This is not a matter of luck or thicker stone. It is the result of a seismic secret engineered into every single, irregular joint. The technology is called dynamic masonry, a form of ancient seismic isolation. Think of it not as a rigid, unyielding barrier, but as a flexible, intelligent matrix. The polygonal shapes we admire for their beauty serve a ruthless, practical purpose. There are no long, straight, continuous mortar lines in these walls. Instead, each quake's energy travels along a complex, zigzagging path through a labyrinth of interlocking angles. The force is broken apart, dissipated into hundreds of tiny friction points between the stones. During a tremor, the entire wall is designed to breathe, to shift and sway as a unified, living skin. The massive blocks rock gently against one another, their weight and angled faces locking them back into place as the shaking subsides. They settle, often with a soft, grinding sigh, returning to a state of perfect equilibrium. It is architecture that dances with the earthquake instead of fighting it. This represents a staggering depth of knowledge, earned not in a single lifetime but over generations of careful observation. The Inca were masterful students of their environment. They watched how landslides behaved on mountain slopes, how river stones settled together in a stream bed, how certain rock formations survived tremors while others crumbled. They conducted, in essence, a centuries-long experiment in structural physics, codifying their findings into a building code written in stone. Their inward-leaning walls are not an aesthetic choice. They lower the structure's center of gravity, making it more stable, like a pyramid. The slight batter or tilt also helps guide seismic energy downward into the solid earth, rather than letting it amplify upward. Every single design element, from the giant foundation stones that anchor the entire structure to the smallest, most intricate polygon, is part of a unified system for survival. This is a technology born of profound respect, even partnership, with a volatile earth. It proves that their lost knowledge was not just about moving or shaping rock, but about listening to the very whispers of the ground they stood upon. And this deep, environmental intelligence would extend far beyond the fortress walls, into the very heartbeat of their empire's infrastructure. The silent stones of Sacsayhuaman speak of a different kind of machinery. To shape and place these megaliths required a force more powerful than any tool, the coordinated effort of an entire society. This brings us to the fourth, and perhaps most human, mystery: the logistics of a pre-industrial workforce. We must envision a scene of breathtaking scale. Historians estimate that constructing the fortress likely required the labor of tens of thousands of individuals, from master stonemasons to teams of haulers and support personnel. This was not a project of slaves, but a coordinated civic duty under a system known as the Mita. Think of it as a rotational labor tax, where communities across the empire contributed a portion of their time and effort to state projects, from building roads to raising temples. The genius of this system was its synchronization with life itself. Work was scheduled around the agricultural calendar, ensuring that people were not taken from their fields during critical planting or harvest seasons. This was social engineering on an imperial scale, a technology of human organization as sophisticated as any pulley or lever. But the logistical challenge was monumental. How do you feed, house, and direct an army of workers on a windswept mountaintop, all without a written language, wheeled carts, or modern communication? The answer lies in the Incas' other legendary invention, their network of storehouses and roads. Food like freeze-dried potatoes and maize, along with tools and supplies, would be transported along the royal highways from state-controlled warehouses to the construction site. A complex hierarchy of administrators, from local foremen to imperial overseers, translated the grand architectural vision into daily tasks through oral commands and knotted string records called quipus. These quipus may have tracked materials, labor rotations, and even architectural plans in a coded format we are still learning to decipher. This administrative machine ensured that the right stones, the right workers, and the right knowledge converged at the right place and time. The true technology here was the seamless fusion of collective purpose and meticulous logistics. It reveals that the indestructible walls were built not just with stone hammers, but with an unwavering social contract and a shared belief in a cosmic order they were manifesting in the physical world. This perspective forces a profound shift. The lost knowledge we seek is not merely a set of physical techniques, but a complete system for harnessing human potential. It was a civilization that could think in centuries and act as one, turning the energy of an empire into a conversation with stone. So if the how of construction lies in this grand organization, we are left to wonder about the why that drove it all, the deeper cosmology that made such a staggering effort not just possible but essential. The fortress was also a celestial observatory, its stones serving as a permanent calendar etched into the earth. Look closely at the walls, and you will find that certain trapezoidal doorways and precisely carved niches are not merely architectural flourishes. They are deliberate sightlines. On the morning of the June solstice, the sun would rise to align perfectly with a specific window, casting a dagger of light across a ceremonial stone. Other apertures framed the rising of Venus or the Southern Cross, connecting the terrestrial fortress to the rhythms of the heavens. This was not a separate function added as an afterthought. It was woven into the very fabric of the design from the beginning. To achieve this, the builders needed a profound command of geometry and long-term astronomical observation. They had to survey the entire site in relation to the distant horizon, calculating angles with exacting precision that would hold true for centuries. How did they perform this complex surveying without written mathematics or optical instruments? The answer may lie in the quiet genius of the Quipu, the knotted string device. While we often think of it as a recording tool for accounts or census data, some researchers believe its complex combinations of knots, colors, and chord positions could encode far more sophisticated information, including architectural plans and astronomical data. A master architect priest, a Quipu might have used these strings as a three-dimensional blueprint, a tactile map of angles and alignments that could be communicated and refined across generations of builders. This transforms our understanding of the construction process. Placing a 100-ton stone was not just an engineering challenge, it was an act of ritual alignment. The subtle convex bulge of a wall, the intentional concave curve of another, these are not random. They may reflect sacred proportions, harmonic ratios that held spiritual significance, creating a structure that resonated with the Inca vision of cosmic balance. The fortress was built to withstand earthquakes, yes, but its deeper purpose was to anchor the human world to the divine order. Every stone laid was a statement of belief, a permanent prayer in rock that said the empire stood where heaven and earth met. This revelation about the walls as a cosmic instrument makes the final, haunting question all the more powerful. If this knowledge was so advanced, so deeply embedded in their culture, how could it simply vanish? Yet the very name fortress may be a profound misdirection. The Spanish who witnessed its defensive use during their final, brutal siege saw only what they understood, a military stronghold. But to view Sacsayhuaman solely through the lens of warfare is to miss its deeper, more essential purpose. Many modern scholars now argue its primary function was not martial but ceremonial, a vast temple complex and royal estate designed for the living heart of the empire. The evidence is carved into the site itself. Look past the imposing walls and you find a sprawling central plaza, large enough to hold tens of thousands of people for public rituals and state festivals. Intricate networks of stone-lined water channels, far more elaborate than any mere garrison would require, snake through the grounds, likely used for sacred rites of purification and symbolic connection to the life-giving forces of the earth. Mysterious underground chambers, known as chincanas, hint at spaces for initiation, storage of ritual objects, or communion with the underworld. This reinterpretation is not a minor detail. It fundamentally changes the motivation behind every perfectly fitted stone. The drive for such supernatural precision and permanence was not just about repelling invaders. It was about projecting the divine, unshakable authority of the Inca state and its ruler, who was seen as a child of the sun. The architecture itself was a form of theological statement, a permanent argument in rock that said this order, this connection to the cosmos, is eternal. This shifts our understanding of the lost technology entirely. It expands to include the psychological and spiritual impact of the built environment. The sheer, awe-inspiring presence of those impossible walls was a deliberate tool of statecraft. To approach them, to run a hand over their seamless joints, was to experience a visceral shock, a feeling that you were in the presence of something beyond human capability. That feeling was the point. It engineered belief, reinforcing the idea that the Inca and their gods commanded forces that defied ordinary understanding. The investment of decades and thousands of lives into such impeccable construction makes perfect sense when you see it as the engineering of power and devotion. The walls were both a physical barrier and a metaphysical one, designed to overwhelm the spirit as much as to stop an army. This dual purpose fuses the practical and the profound into a single intention, revealing that the greatest strength of Sacsayhuaman may not have been in its resistance to earthquakes, but in its power to convince everyone who saw it that the empire was as permanent and as perfectly ordered as the stones themselves. But the true signature of Sacsayhuaman is written in a series of staggering, angular lines. Rising in 3 colossal tiers, the zigzag walls carve a serrated silhouette against the Andean sky, a design so bold it feels less like architecture and more like a geological event. This is the fortress's most iconic feature, the teeth of the stone puma made manifest. Yet to see them only as a fearsome symbol is to miss the fifth and perhaps most daunting mystery, the sheer precision of their execution. Each zigzag is composed of dozens of the same colossal polygonal stones, but here they are arranged not in an organic puzzle, but into long, razor-straight segments that meet at sharp, consistent angles, stretching for hundreds of feet across the hillside. Creating a single, tight-fitting polygonal block is a marvel, but organizing hundreds of them into these massive, geometric patterns represents a leap into a different realm of planning. The logistical challenge is mind-bending. First, the master architects had to survey the entire hillside, plotting the precise course of 3 separate, interlocking zigzag lines. They had to account for the slope, the bedrock, and the visual impact from every approach. Then, they had to translate that grand vision onto the ground, marking where each multi-ton stone would ultimately rest, ensuring that every angle was perfect and every line remained true. This would have required sophisticated string line techniques, using cords stretched between stakes to create the guiding lines for the walls, and constant verification with simple but effective tools like plumb bobs and water levels to check for vertical and horizontal alignment over vast distances. One misaligned cornerstone, one angle off by a few degrees, and the entire majestic symmetry would collapse into visual chaos. The zigzag design was a brutal masterpiece of military engineering. For any attacking force, those protruding angles created deadly funnels, exposing them to enfilading fire from 3 sides at every turn. There was no safe approach, no blind spot to hide an assault. But this defensive genius was born from a construction miracle. It speaks to a level of project management and quality control that spanned decades. It hints at a master blueprint, a detailed plan that existed not on parchment, which the Inca lacked, but as a living model in the minds of the master architects, the Quipu. This knowledge was then transmitted through a rigorous, silent apprenticeship. A young mason would not read instructions, he would watch and listen and feel the stone, learning the rhythms of alignment and angle through his hands and eyes, absorbing a tradition that turned a chaotic hillside into a symphony of geometric order. The zigzag walls stand as the ultimate proof that their lost technology was not just in the craft of the individual stone, but in the orchestration of the whole, a collective vision held so firmly that it could bend a mountain to its will. This intellectual framework was the domain of the Amota, the empire's master teachers and priests. They were the living libraries of the Inca world, entrusted with everything from astronomy and history to engineering and theology. In a society without a common written alphabet, these sages did not merely recite stories. They preserved entire systems of knowledge through a disciplined, multi-generational oral tradition. The plans for Sacsayhuaman, with all its celestial alignments and seismic secrets, would have first existed as a complex concept in the mind of an amator. This individual or council of elders would have translated that vision into a teachable format, using the knotted quipus not as a written blueprint, but as a sophisticated mnemonic device. Each knot's position, color, and type could trigger the recall of a specific measurement, a material list, or a ritual sequence. Apprentice builders learned not from scrolls, but from watching, listening, and participating in the creation of physical scale models made from clay or stone. They memorized the chants, the stories, and the procedures that encoded the building's sacred geometry. This method of knowledge transfer was itself a sophisticated technology, a living, adaptive system of data storage that was perfectly suited to the culture that created it. It allowed for nuance, for on-site improvisation within a strict conceptual framework, and for the seamless integration of spiritual meaning into every technical step. The tragedy and the core of the lost technology idea is that this entire intellectual ecosystem was catastrophically fragile. With the Spanish conquest came the deliberate suppression of Inca religion and elite classes. The amator, as the guardians of this knowledge, were targeted. As they passed the intricate oral traditions, they carried the precise meanings behind certain knot patterns, the subtle reasons for a specific stone's angle. The chants that accompanied a foundation laying faded into silence. What remained were the physical stones, magnificent but mute. Written Spanish chronicles captured only the outsider's perspective, often missing the deeper principles entirely. So when we say the technology is lost, we are not just speaking of a missing tool, but of a broken chain of whispered wisdom. The walls stand as a perfect, unanswered question, a testament to a way of thinking about the world that was preserved not on paper, but in the collective memory of a people, a memory that was ultimately scattered to the wind. This profound loss forces us to look at the stones with a new humility, understanding that the greatest secret they hold might be how an entire civilization thought, learned, and remembered. The walls of Sacsayhuaman are not an isolated mystery, but part of a global conversation written in stone. From the pyramids of Giza to the silent Moai of Easter Island, our planet is dotted with monuments that defy our understanding of pre-industrial capability. Each of these sites presents a unique puzzle, yet placing the Inca fortress beside them reveals something crucial about the nature of ancient genius. The Great Pyramids, for instance, are a breathtaking feat of mass and alignment, built with immense, precisely cut rectangular blocks. Their construction speaks to a society that mastered linear geometry, ramps, and large-scale labor organization on a flat desert plateau. Stonehenge, with its towering sarsen stones transported over great distances, showcases a profound understanding of astronomy and communal effort in a very different landscape. The Moai of Rapa Nui tell a story of incredible sculptural skill and transport across rugged terrain, a testament to a culture's devotion and resourcefulness on a remote island. Yet, in this family of global megaliths, Sacsayhuaman stands apart. Its signature is not in the size of a single block, though they are colossal, nor in the distance they were moved, though that journey was immense. Its true distinction lies in the intentional, radical irregularity of its design. Where Egyptian and many other builders sought perfection in uniformity, creating straight lines and right angles, the Inca master masons embraced complexity. They sought strength not in identical, repeating units, but in a chaotic-looking mosaic of unique, interlocking shapes. This was not a lack of ability to cut straight lines, it was a deliberate, sophisticated choice. The polygonal, mortarless fitting we see in Peru is arguably the most advanced ancient solution to a specific, relentless problem: seismic activity. The pyramids did not need to dance with earthquakes. The stones of Stonehenge do not lock together, and the Moai stand as solitary sentinels. Sacsayhuaman's technology was engineered for a dialogue with a trembling earth, making its geometric complexity not just an artistic style, but a fundamental survival mechanism. This comparative view is liberating. It dismantles the idea of a single, universal lost technology passed between ancient cultures like a secret blueprint. Instead, it reveals a more fascinating truth: different civilizations, facing different environmental challenges and guided by different cultural imperatives, arrived at brilliantly different engineering solutions. The Egyptians had the Nile, flat terrain, and a religious focus on the afterlife, leading to the timeless static pyramid. The Inca had the volatile Andes, a cosmology of living landscapes, and a need for structures that could endure both time and tectonic fury, leading to the dynamic, breathing walls of Sacsayhuaman. Their technique was a hyper-localized innovation, a suite of knowledge refined over generations specifically for the mountains they called home. It pushes us to ask not what universal secret they knew, but what was so special about their environment, their worldview, and their social organization that allowed this particular form of genius to flourish. The answer lies not in a mythical tool, but in the unique convergence of place, purpose, and people that turned a hilltop into a testament to resilience. Beneath the awe of the visible walls lies a hidden masterpiece of foresight. While our eyes are drawn upward to the colossal zigzags and polygonal puzzles, the true genius of Sacsayhuaman begins where the light fades, deep within the earth itself. The builders did not simply place their megaliths upon the hilltop. They first performed a kind of geological surgery. They excavated down to the living bedrock, the unshakable heart of the mountain, and then meticulously leveled and prepared its surface to receive the first foundational stones. This was not a crude foundation, it was a custom-made socket, ensuring that every single multi-ton block above would rest on a perfectly stable, unified base that moved as one with the mountain during a quake. But their understanding of the earth went beyond solid rock. It extended to the element that can undo the mightiest fortress over time: water. The Andes experience torrential seasonal rains, and water pooling behind or beneath a wall creates two silent killers: hydrostatic pressure and frost heave. Pressure from trapped water can push walls apart, while water freezing and expanding in cracks can slowly pulverize stone from within. The Inca engineers anticipated this centuries before modern hydrology was formalized. Woven throughout the entire site, often invisible to the casual observer, is an intricate network of stone-lined drainage channels. These carefully sloped conduits were designed to capture rainwater the moment it hit the ground, channeling it away from the foundations and harmlessly dispersing it down the hillside. They managed water flow not as an afterthought, but as a foundational principle, treating the entire fortress as a living system that needed to breathe and shed moisture. This underground technology reveals a staggering level of holistic planning. The architects thought in 4 dimensions, considering not just the structure's immediate grandeur, but its behavior across centuries of storms, freezes, and tremors. They understood that indestructibility was not just about strength against a single, sudden force, but about resilience against the slow, patient siege of time and climate. This mastery of hydrogeology, of working with the mountain's own water, is a quiet testament to a culture that listened to the land. It proves their technology was not a collection of isolated tricks, but an integrated philosophy of building that extended from the deepest bedrock to the highest stone, a seamless bond between human intention and the enduring logic of the earth. The final touch on these stones is a language of texture. Walk along the base of the great walls and run your hand across the rock. Your fingers will trace 2 distinct stories. Some stones feel like glass, a surface so unnaturally smooth it seems to have been poured rather than carved. Others retain a rough, raised boss, a kind of textured knob left deliberately proud of the surface. This was not an unfinished job, but a conscious choice, a sophisticated final stage in the building process. To take a block of volcanic andesite, a material as hard as granite, and grind its face to a mirror-like polish without a single metal tool or electric sander is a feat that borders on the obsessive. The likely method speaks to immense patience. Workers may have used slabs of an even harder stone, like quartzite, rubbing them for days or weeks across the surface with a slurry of water and fine abrasive sand, perhaps quartz itself. This is a process of subtraction by a million tiny scratches, a gradual wearing away of the rock until it achieved a uniform, almost reflective sheen. Another, more speculative theory involves the careful application of heat. By repeatedly heating the stone's surface and then cooling it, they could create a thin, glass-like vitrified layer, a permanent seal that would also shed water and resist weathering. The pattern of which stones received this treatment is telling. Often, the most visible faces, the ones that would catch the light or be touched in ceremonies, were the ones polished to perfection. The bosses, meanwhile, might have served a practical role during construction, providing a grip for ropes and levers to position the massive blocks, and were left as a testament to the process itself. This attention to surface detail reveals a culture that saw no division between the practical and the beautiful. The polish was not mere vanity. It enhanced the stone's durability by sealing its pores against water and frost, and it transformed the wall into a living canvas of light and shadow. At sunrise, the smooth faces would gleam while the bosses cast deep, shifting patterns, making the static stone seem to move. It was the final, masterful sentence in a long declaration written in rock, proving their command over the material extended from the quarry to the very last deliberate stroke. But perhaps the most profound technology was not in the hand but in the heart. For the Inca, stone was far more than a building material. It was Huaca, a living entity imbued with spiritual essence, a fragment of the earth's own consciousness. This belief transforms every act of construction we have examined from a technical feat into a sacred dialogue. To quarry a stone was not to extract an inert resource. It was to respectfully ask a piece of the mountain to take on a new role. To shape it was to engage in a conversation, listening to its grain and form, and to place it within the wall was to integrate it into a greater, living whole. This worldview makes the peculiar, almost organic shapes of the polygonal blocks resonate with deeper meaning. While their interlocking design served a brilliant seismic function, some researchers suggest their forms may also hold a hidden language. Look closely at the silhouettes. That block with a sweeping curve could echo the back of a puma, the empire's sacred symbol. Another's jagged profile might mirror a distant, sacred mountain peak on the horizon. A cluster of stones might be arranged to reflect the constellation of the Llama, a celestial herd vital to Andean cosmology. If true, the walls become a vast lithic text, a story of the Inca world carved directly into the fortress's skin. This symbolic layer implies that the lost technology we seek included a vital ritual component. The selection of a specific boulder from the quarry may have been guided by an oracle or a dream. The shaping of its final form might have been done to honor a specific deity or to harness a spiritual force believed to reside within that particular stone. The act of fitting it perfectly against its neighbor was not just about structural integrity. It was about creating harmony between two spiritual entities, ensuring the entire assembly vibrated with balanced, sacred energy. This perspective makes the obsessive pursuit of perfection suddenly clear. In a worldview where architectural integrity was synonymous with cosmic and social harmony, a single poorly fitted stone was not just an engineering flaw. It was a spiritual dissonance, a crack in the order of the universe itself. The motivation for such flawless work stemmed from a place far deeper than royal command or civic pride. It arose from a collective desire to maintain the balance of the world. This intertwining of the practical and the metaphysical challenges our modern, purely materialist interpretations. It suggests that to truly understand Sacsayhuaman, we cannot separate the engineering from the belief system that powered it. The genius of the walls may lie precisely in this fusion, where the spiritual imperative for harmony directly produced the physical reality of indestructibility. The stones were not just placed, they were convinced to stand together forever. A new generation of explorers now approaches the walls not with ropes and hammers, but with lasers and radio waves. Modern scientific investigations have ushered in a quiet revolution, using tools like ground-penetrating radar, three-dimensional laser scanning, and drone-mounted photogrammetry to see the fortress as never before. These technologies map every contour and crevice with millimeter precision, creating a digital twin of Sacsayhuaman that can be studied from anywhere in the world. The scans reveal secrets invisible to the human eye, subtle patterns in the stone fitting that suggest a consistent methodology, and internal structures hidden beneath the soil. They provide hard data, exact measurements of angles, volumes, and the minute displacements caused by centuries of earthquakes, allowing engineers to run sophisticated simulations of the wall's legendary dance with seismic forces. This flood of objective information is invaluable. It definitively rules out some of the more fantastical fringe theories, proving, for instance, that the stones were not cast from a liquid geopolymer mixture, but are indeed solid quarried rock. Yet for all their power, these tools have a profound limitation. They can document with exquisite detail what was built, but they remain silent on the how. A laser scan can show you the perfect seam between two polygonal blocks, but it cannot tell you the chant the mason hummed while grinding the stone, or the social contract that brought him to the mountaintop. The data provides the questions in sharper focus, not the answers. This scientific approach represents a hopeful new chapter, a bridge of inquiry built with the technology of the present, reaching back to decode the technology of the past. It creates a permanent digital record for future generations, ensuring that even as the stones slowly weather, their exact form is preserved. This meticulous mapping, however, often leads us not to a single truth, but to a wider field of possibility, where data and deduction give rise to the most hotly debated theories of all. The silence of the stones sometimes speaks in the language of science fiction. In the vast space between what we see at Sacsayhuaman and what we can comfortably explain, a compelling narrative has grown, one that reaches beyond the mountains of Peru and into the stars. This is the realm of the extraterrestrial and hyper-diffusionist theories, ideas that suggest the precision and scale of the fortress are simply too great to be the work of the Inca alone. Proponents of these views argue that the technology required to fit multi-ton stones with such perfection, or to move them across impossible terrain, must have come from an outside source, whether that be visitors from another world or a now vanished, supremely advanced global civilization that seeded knowledge across the ancient world. These theories are undeniably captivating. They offer a clean, dramatic answer to a stubborn puzzle, transforming a historical mystery into an epic of cosmic contact or forgotten golden ages. They resonate because they acknowledge the awe we feel, giving a name to that sense of confronting something that feels, in a very real way, superhuman. Mainstream archaeology and history, however, stand firmly against these interpretations. Scholars point to the complete absence of any physical evidence, such as anomalous materials or technologies, that would support such extraordinary claims. More importantly, they argue that these theories often stem from a subtle, persistent bias, an underestimation of the profound ingenuity, patience, and sophisticated social organization of indigenous cultures. To attribute their achievements to outside forces is, in a sense, to rob them of their own legacy, to deny the Inca their rightful place as masters of their environment and brilliant engineers in their own right. Yet, to engage with these ideas is not to endorse them, it is to understand why they persist. They are a symptom of the profound mystery the site evokes, a testament to the limitations of our conventional historical narratives when faced with such a staggering artifact. They force a vital, uncomfortable question upon us. What does our scientific skepticism protect, and what potential insights might we inadvertently dismiss by refusing to look at any anomalous evidence, any stubborn outlier that does not fit our established models? This intellectual tension is not a dead end, but a crucial crossroads. It pushes us away from the sensational and back toward the earth, not to settle for simple answers, but to pursue more radical yet grounded possibilities that still honor the human hands that built this place. The surface of some stones feels almost too perfect. On certain blocks, especially those with flowing, rounded corners, the andesite lacks the expected chisel marks or abrasive striations from grinding. Instead, it presents a strangely uniform texture, as if the rock itself once softened and settled into its current form, like clay molded around a corner. This subtle detail has given rise to one of the most scientifically provocative alternative theories, the idea of ancient geopolymer concrete. Imagine not a team of masons carving a 100-ton block, but a crew mixing a sophisticated slurry in large containers. This theory proposes that the Inca might have used a recipe of locally available materials, crushed volcanic rock, lime from burned limestone or seashells, and natural acidic binders from plants to create a pourable, cement-like paste. This paste could have been poured into formwork, or even used as a thick mortar to fill gaps and mold the final, seamless joints between stones. The process would not create a fake rock, but a true synthetic stone, a geopolymer, with a chemical composition nearly identical to the natural andesite around it. Proponents point to the uncanny, sometimes plastic-looking deformation of stone around tight corners, and the baffling absence of tool marks on certain expansive, smooth surfaces as potential evidence of a casting process. For them, the mystery shifts dramatically. It is no longer about how they cut the stone, but about what they might have made it from. This is a technology of transformation, a lost recipe that turned earth and plant into indestructible architecture. The scientific community remains deeply skeptical, as core samples and standard geological analysis consistently identify the stones as natural, quarried rock. No definitive residue of a binding agent has been proven at Sacsayhuaman itself, yet the enduring power of this hypothesis is not in its likely truth, but in the profound question it forces us to confront. It expands the very definition of their possible toolkit into the realm of chemistry and material science. It suggests that the lost knowledge could have been a formula, a carefully guarded mixture known only to a few master builders, a secret that died with them. Whether they carved the stones or cast them, the outcome is the same, a wall that has endured for centuries. The debate itself underscores a humbling reality. Our modern tools can tell us what the stone is, but they still cannot tell us with absolute certainty how it came to be in that impossible, perfect shape. This uncertainty leaves the door open to wonder, and to the next, even more elusive layer of the mystery, the possibility that the true secret was not in the hand or the recipe, but in the mind, a different way of perceiving the physical world itself. The gap between theory and reality is often measured in sweat and stone. To truly test the limits of the possible, a dedicated group of modern stonemasons, archaeologists, and engineers have taken on a remarkable challenge. They have stepped away from their power tools and computers to attempt what seems unthinkable, to replicate the Incas' work using only the basic toolkit history has granted them: stone hammers, wooden levers, fiber ropes, abrasive sand, and human muscle. This field, known as experimental archaeology, turns speculation into a physical, grueling test. The results of these hands-on experiments are a profound mix of revelation and deepening mystery. Teams of volunteers working for weeks on a single, much smaller block have demonstrated that the basic principles absolutely work. With a stone hammer, you can fracture a granite boulder along its natural grain. With a wooden lever and a team of people rocking in unison, you can inch a multi-ton stone forward. With a slurry of sand and water and days of relentless grinding, you can smooth a rock surface. These experiments prove the fundamental feasibility. They show that the walls were not built by magic but by human hands. Yet, this validation comes with a sobering caveat. The pace revealed by these trials is agonizingly slow, a crawl that makes the scale of Sacsayhuaman seem almost incomprehensible. To shape and fit just one of the fortress's smaller stones using these basic methods could take a small team many months. When you multiply that by the thousands of blocks in the complex, the math stretches into centuries, far beyond the historical timeline we believe the Inca had. This creates what researchers call the time-cost problem. The experiments confirm that the basic techniques work, but they cannot explain how the project was completed with the efficiency and speed that the historical record implies. They highlight a staggering, almost unimaginable investment of coordinated human energy, but they also point to a missing multiplier, a clever shortcut or a refined method that has been lost to us. Perhaps it was a more efficient quarrying technique, a smarter way to transport the megaliths that reduced friction to a minimum, or a masterful organizational system that eliminated all downtime. The modern attempts, covered in dust and exhaustion, leave us with a humbling respect for the ancient builders and a clearer question than ever. We now know what was possible with sheer effort, but we still do not know how they made the impossible merely difficult. The true lost technology may not be a single tool, but a symphony of optimized processes that turned a mountain of labor into a masterpiece within a single generation. The Conquest arrived not with a single battle, but as a slow, suffocating shadow. When Spanish forces entered the Andes in the 16th century, they brought with them a worldview that saw the Inca Empire not as a civilization to be understood, but as a kingdom to be plundered and a faith to be erased. This collision was catastrophic for the intricate knowledge systems that built Sacsayhuaman. The Amorta, the revered teachers and living libraries, were specifically targeted. As guardians of history, astronomy, and engineering, they represented the intellectual spine of the empire. Many were lost to the violence and disease that swept through the region, while others were silenced, their teachings forbidden as heretical. This was not an accidental loss, it was a deliberate severing of the cultural nerve. The physical tools of this knowledge faced a similar fate. The Quipus, those complex knotted strings that may have encoded everything from tax records to architectural plans, were systematically gathered and burned by zealous priests who saw them as idolatrous objects, as pagan witchcraft. Each bundle of cords that crackled in the fire represented a volume of unreadable history, a set of instructions for aligning a wall with the solstice sun, or a census of the workers who moved the stones. The oral traditions, passed meticulously from master to apprentice over generations, were disrupted and fragmented. The young masons who might have learned the final secrets of fitting a 12-sided stone were no longer taught, their teachers gone, their purpose redirected by a new colonial order. The conquistadors themselves, driven by a thirst for gold and a mandate to convert, had zero interest in the technical secrets of a fortress they viewed as a pagan stronghold. They saw the result, the imposing walls, but had no curiosity about the process. Why would they care about the properties of a specific plant juice or the chant that accompanied the laying of a cornerstone? Their focus was on extraction, both of wealth and of souls. This cultural and intellectual rupture is likely the true grave of the lost technology. It was not lost in a single, dramatic cataclysm, but in the slow, systematic dismantling of the very society that created, understood, and perpetuated it. The knowledge became a set of answers without questions, a symphony with no one left who could read the score, and in a final, deeply symbolic act, the walls of Sacsayhuaman themselves were not just ignored, they were cannibalized. The Spanish colonists, building their own churches and mansions in the new city of Cusco below, saw the fortress as a convenient quarry. They pried many of the beautifully fitted stones from the upper sections, rolling them down the hill to serve as foundations for their own architecture. It was a literal and metaphorical overwriting, using the bones of the Inca achievement to build the seat of a new power. This historical context is essential, for it explains why the secrets of Sacsayhuaman are not merely buried, waiting to be dug up. They were actively erased, scattered, and silenced. The silence we hear when we look at the walls today is not a natural quiet, but one imposed by history. It forces us to ask a different kind of question. If the builders could speak, what would they tell us about the true cost of what was lost? Beneath the sunlit walls lies a world of perpetual shadow. Local stories have long whispered of chincanas, vast underground labyrinths that snake beneath the fortress, connecting to distant temples and even the old city of Cusco far below. These tales speak of hidden chambers filled with treasures, lost knowledge, or the silent echoes of ancient ceremonies. While modern exploration has confirmed the existence of some tunnels and chambers beneath Sacsayhuaman, their true scale and original purpose remain shrouded in earth and speculation. This is the 10th mystery, a reminder that the genius of this place extends into the darkness below our feet. Were these passages simply practical, part of that brilliant water management system, channeling groundwater away from the foundations? Could they have served as secure storage for ceremonial objects or grain, leveraging the Earth's constant temperature? Or were they something more profound, escape routes for royalty in times of siege, or sacred pathways meant for ritual journeys into the symbolic underworld? The very name Chincana implies a place of getting lost, a maze designed for disorientation, which suggests a purpose beyond mere utility. If the Inca applied even a fraction of their surface engineering skill underground, these tunnels represent a parallel world of construction. Excavating stable tunnels in loose Andean soil without modern shoring is a formidable challenge in itself. The possibility that they form a coordinated network hints at a subterranean mirror to the geometric order above, a hidden dimension to their sacred landscape. This enigma forces a powerful shift in perspective. We have been studying a magnificent open-air achievement, but we may have only been examining the roof of a much larger structure. The true complexity of Sacsayhuaman could be inverted, with its most secret workings buried safely out of sight. The chincanas symbolize the deeper layers of this culture's ingenuity that remain literally underground, waiting in the dark. They remind us that for all our scanning and study, we are still only interpreting the visible chapters of a story that continues deep into the earth. Yet the echo of that ancient skill never fully faded from the valleys. If you walk the streets of Cusco today, you can witness a living, if quieter, legacy in the stone beneath your feet. The famous Inca walls, those seamless foundations upon which Spanish colonial buildings now sit, demonstrate the same polygonal fitting and precise joinery, just often on a more modest human scale. These are not the towering zigzags of Sacsayhuaman, but the bones of the city itself, holding up centuries of newer history with the same unshakable patience. This is where the story of a lost technology finds a vital, living thread. The knowledge of fine stonework did not vanish in a single moment. It transformed, persisting through the colonial era and into the present in the hands of modern Andean masons. In workshops and on construction sites across the region, you can still find craftsmen using techniques passed down, generation to generation, in a direct, though diluted, lineage. They work with smaller stones, often using modern cement for mortar, but the core philosophy remains recognizable. The careful selection of rock, the intuitive understanding of its grain, the practice of test fitting and grinding, and above all, the profound respect for the material as something to be collaborated with, not dominated. Anthropologists and historians study these contemporary artisans not to find a secret manual, but to gather precious clues. By watching how a mason today uses a simple hammer and chisel to find a stone's natural fracture point, or how a team rhythmically rocks a heavy block into place with wooden poles, we catch glimpses of the larger orchestration that must have been required for the megaliths. This is tactile knowledge, wisdom stored in the muscles and the eyes, learned not from books but from doing. The continuity is fractured, yes, and the grand cosmological framework is gone, replaced by practical necessity. But the enduring foundation of the technology reveals itself not in a mythical tool, but in a mindset. It is the principle of patience over haste, of observation over assumption, and of a deep, almost conversational respect for the stone itself. This living tradition suggests that the true secret of Sacsayhuaman may have always been these human qualities, scaled up by a society that made them a sacred imperative. The walls stand not as a monument to a single forgotten trick, but to what people can achieve when their culture elevates patience and precision to an art form. And this realization shifts the final question from one of mechanics to one of meaning, asking what such a pursuit tells us about the civilization that considered it worth a lifetime of effort. The stones of Sacsayhuaman, therefore, ask us to redefine our search. The lost technology we have been chasing is not a singular object, not a magical plant or a forgotten alloy. It is something far more profound and far more fragile. It is the complete, integrated system of a civilization operating at its peak. Imagine it as a four-part harmony, where each voice is essential to the whole. The first voice is advanced empirical engineering, the hard-won knowledge of how to make a structure dance with earthquakes and shed water like a mountain slope. The second is master-level material science, an intimate, almost spiritual understanding of stone, from reading its grain in the quarry to polishing its face to a reflective sheen. The third is unparalleled social organization, the administrative and logistical genius that could feed, house, and direct the will of thousands toward a single, multi-generational goal. And the fourth, the foundational melody that guided all the others, is a holistic cosmological framework. This was the belief system that saw a fortress as the head of a sacred puma, that aligned walls with solstice sunrises, and that treated every block as a living participant in a divine order. This framework provided the ultimate motivation, the reason why such obsessive perfection was not just desirable but spiritually necessary. The loss we mourn, then, is not the misplacement of a tool manual. It is the catastrophic disintegration of the entire cultural ecosystem that could conceive, coordinate, and execute such a project with such flawless, unified intent. The Amata priests, the Quipu records, the oral traditions, the social contract of the Mita, the shared sacred geography, all of these were the operating system for the technology. When that system was fragmented by conquest and cultural suppression, the ability to run the program vanished. We are left with the breathtaking output, the final product, but the source code has been erased. This synthesis moves us from a frustrating hunt for a silver bullet to a humbling appreciation of a golden age of integrated knowledge. It forces a pivotal shift in perspective. We stop asking how they cut the stones, and we start asking how they thought about the world in a way that made cutting stones with such perfection the only acceptable outcome. This realization frames our final and perhaps most important reflection. What does this integrated wisdom from the past have to say to our fragmented, specialized world today? Our modern world is built on a different kind of calculation, one that often prioritizes speed and cost over longevity. We construct with the expectation of decades, not millennia, and our landscapes are littered with the shells of buildings that have outlived their usefulness or structural integrity. Against this backdrop, the enduring silence of Sacsayhuaman's walls is not just a mystery, it is a profound critique. In an age of climate crisis and disposable construction, This ancient fortress emerges not as a relic, but as a masterclass in principles we are now desperately trying to relearn: sustainability and resilience. Every aspect of its being, from its procurement to its purpose, offers a stark contrast to our own practices and a potential guide forward. Consider the sheer economy of its construction. It was built using only local materials, the very rock of the mountains it stands upon. There were no supply chains stretching across oceans, no carbon-intensive transport of foreign steel or concrete. The energy input was human power, harnessed through a social system that distributed the effort across an entire society. This created a structure with an almost negligible carbon footprint by today's standards, one that has required virtually zero maintenance for over 500 years. Its durability is the ultimate form of sustainability, a building that never needed to be torn down and rebuilt, that never generated waste through decay or obsolescence. In our pursuit of green building standards, we are now striving to use local, renewable materials and design for deconstruction or eternal life. The Inca were already there. They built with the understanding that the most sustainable material is the one that already exists in place, and that the most efficient energy is a coordinated community. Then there is the lesson written in the joints, a direct answer to one of our greatest modern vulnerabilities. In earthquake zones from California to Japan, engineers are pioneering base isolators and flexible frames, complex and expensive technologies designed to let buildings sway rather than break. Sacsayhuaman's polygonal masonry is a primordial, elegant version of the same idea. It proves that resilience does not always require high-tech widgets. It can be encoded into the very geometry of the materials themselves. For regions facing increasing seismic activity, studying these ancient techniques is not nostalgia. It is a form of forensic engineering. By simulating how these irregular blocks dissipate energy, we might uncover principles that can inspire new, simpler, and more accessible forms of seismic design, especially for communities that cannot afford the most advanced modern solutions. The fortress demonstrates that the best defense against a volatile Earth is not rigid resistance but intelligent flexibility, a lesson as vital today as it was in the 15th century. Perhaps the most poignant contrast lies in the human element. Our construction sites are dominated by machinery, replacing physical labor with fossil-fueled power. The Inca model was the opposite. It amplified human labor through impeccable organization and shared purpose. The Mita system was a technology of social cohesion, turning a monumental engineering challenge into a collective ritual that reinforced cultural identity and distributed the burden across the empire. This speaks to a value system where a project's worth was measured not just in its completion, but in the community it built along the way. In an era where automation and efficiency often come at the cost of meaningful work and social fragmentation, this ancient approach poses a challenging question. What do we lose when we remove the shared, physical endeavor from the creation of our world? The walls of Sacsayhuaman suggest that the strength of a structure may be intrinsically linked to the strength of the social fabric that wove it. Ultimately, to study this so-called lost technology is to engage in more than an historical exercise. It is an invitation to re-evaluate our own values around permanence, community, and our relationship with the natural world. We live in a throwaway culture, but these stones ask us what it would mean to build like ancestors, to think in time frames that span centuries. They challenge the modern notion that newer is always better, reminding us that some of the most advanced solutions are already here, weathered by time but sharper in their relevance. The fortress does not offer a blueprint we can copy, but a mindset we can adopt, one of deep listening to the environment, of patience over haste, and of building not just for the present need, but for the unknown children of the distant future. In its silent, steadfast presence, Sacsayhuaman becomes more than a wonder of the ancient world. It becomes a mirror, reflecting back our own choices and asking us what we truly intend to leave behind. Centuries of scrutiny have not dulled the mystery, they have simply sharpened the questions. For all we have pieced together about the walls of Sacsayhuaman, fundamental gaps in our understanding remain stubbornly intact. The most basic sequence of events is still debated. Did builders work on all three terraces simultaneously, or did they complete one majestic zigzag before moving to the next? How did they manage the flow of materials and workers on such a confined, steep site without creating chaos? We have theories, but no definitive timeline etched in the stone itself. This is where the next generation of inquiry begins, armed not with speculation, but with tools that can see the invisible. Sophisticated chemical analysis, for instance, might finally settle the debate about surface treatments. By taking microscopic samples from the stone, especially from the deepest joints and the polished faces, scientists could search for residual traces of organic compounds, oxalic acid from plants, or binding agents that could hint at a lost slurry or polish. Similarly, analyzing the microscopic wear patterns on the rock could reveal the specific mineral composition of the abrasives they used, telling us exactly what they were grinding with. Beyond the stones themselves, the surrounding landscape holds untold stories. Advanced LiDAR technology, which uses laser pulses to map terrain through dense forest cover, could scan the valleys and hills between the quarries and the fortress. This might reveal the ghostly imprint of forgotten transport roads, temporary work camps, or even ritual pathways, mapping the entire logistical network that fed the construction. The future of this mystery lies not in a single field of study, but in a meeting of minds. It requires archaeologists to frame the historical questions, geologists to analyze the stone, engineers to model the structural physics, and modern master stonemasons to provide the tactile, practical insight that no machine can replicate. This interdisciplinary conversation is crucial, but it must be guided by a profound and ongoing respect. True understanding cannot be reached without the continued inclusion of indigenous knowledge and perspectives, the cultural memory and oral histories carried by the descendants of the builders themselves. Their insights into the landscape, their traditional practices, and their cosmological framework are not secondary data. They are essential context for interpreting what the scientific instruments detect. This quest is very much alive. Each new tool, from ground-penetrating radar to three-dimensional modeling software, gives us a fresh lens, but it also reveals new layers of complexity. The enduring enigma of Sacsayhuaman ensures it will remain a beacon, a focal point for anyone who believes the past is not a closed book, but a living conversation. It stands as proof that our ancestors achieved wonders we are still learning to see, and that their most profound secrets are not merely artifacts to be catalogued, but lessons in ingenuity, resilience, and perspective waiting to be understood. The silent lecture in stone has reached its final point. Sacsayhuaman's indestructible walls are far more than a tourist attraction. They are a permanent challenge etched into the landscape, questioning our deepest assumptions about history, human potential, and the very meaning of technology itself. Our journey has taken us from the whispers of legendary plants that softened rock to the hard, silent data of modern laser scans. We have traced the sacred lines of a stone puma across the hills and felt the immense physical toll of moving a 100-ton block from the quarry. What we have found, in the end, is not a single lost tool or a forgotten blueprint. The true lost technology is a magnificent tapestry, a fabric woven from three inseparable threads. The first thread is empirical genius, the hard one, practical knowledge of how to make a structure dance with earthquakes. The second is a profound spiritual vision, a cosmology that saw architecture as a dialogue with the living earth and the heavens. The third is social mastery, the logistical and organizational miracle of aligning the will of thousands toward a single, multi-generational purpose. While we may never uncover every precise detail of the method, the walls themselves stand as the ultimate, unassailable evidence that it was done. They are a testament written in andesite to the breathtaking heights of human creativity, patience, and collective perseverance. Let these stones be a reminder that history is rarely a simple story. It is a complex, three-dimensional puzzle, rich with gaps and questions, always waiting for curious minds to lean in and engage. If this exploration has shifted your view of the ancient world, we would love to hear your thoughts in the comments below. Subscribe to journey with us as we continue to uncover more profound mysteries of our shared past.